This video introduces the sample database we'll be using throughout the course. So this database is called the Kware database. It's a database that's used by a company called Kware, a company that sells kitchenware products on the internet. Now, we said that a relational database consists of a collection of tables. The Kware database consists of 4 tables. A table that describes products sold by Kware, a table that describes customers of Kware, and 2 tables describing sales orders that are placed by customers for products sold by Kware. So sample data for the customer and sales order tables are shown here. So in the sample data that we'll use in the Kware database, you'll only find a few rows in each table, and that will mean that it's fairly easy for you to check that your SQL query that requests data from the Kware database is working correctly. So products, customers and sales orders are examples of things of interest to the Kware company about which data needs to be recorded to help Kware run their business. Now, the technical term for a thing of interest about which we need to record data in a database is entity or entity type. So in a relational database then, we hold descriptions of entities and relationships of interest between those entities. So customers and sales orders are examples of entity types about which we need to record data in the Kware database. So a single customer, a customer entity, is described by a single row in the customer table. The customer is described by a CID value, that's a customer ID value, a customer identifier. Every customer has their own unique customer ID. So a CID value, the customer name, street, suburb, state and postcode, forming their address. Whether or not they receive a discount, so commercial customers do receive a discount, retail customers do not, and their email address. So we've got 6 customers described in our customer table, and we've got 5 sales orders. So a sales order entity is described in the Kware database by an SOID value, that's a sales order ID, a sales order identifier. Each sales order has a unique sales order ID value. So a sales order is described by an SOID value, a CID value, that's the CID value of the customer who placed that order, a sales order number, so this is the number that appears on the printed sales order, the date of the sales order, the full price of the sales order, any discount that applied, the final price after the discount, the amount paid against the sales order by the customer, and the status of the sales order. So when a sales order is first created, it has a status of open, and the customer can make changes to the details of that sales order. But once the order is placed, the customer can no longer make any changes to that sales order. So here we see details of entities of interest recorded in the database, and also a relationship of interest. So a relationship between customers and sales orders is important. We need to know for each sales order who was a customer who placed that order. That's achieved by holding the CID value for the customer as a part of the description of the sales order. So entities and relationships are the things of interest about which we need to hold data in the relational database. Now, the study guide has a number of interesting questions about the sample data that's provided. Have a go at these questions now, and if you're in class, speak to your neighbour, see how your answers to these questions compare with the answers of your neighbour. Now, we provide a Microsoft Access version of the Kware database, and you can obtain that database from the Week 1 webpage. So click here and save to my desktop, and then I'll double click on that file to open it up. Now when you download databases that we provide in this course, you may sometimes come across this message at the top, which is a security warning. It says that Microsoft Access is not confident that the content of that database file is secure. So if you click options here, you can simply enable all of the content in that database, or another option is to move that file to a trusted area. And if you click here to open the Trust Center, you'll see a list of the trusted locations that are known to that copy of Windows. For now, I'll just click enable this content, at which point that warning at the top disappears. So here are our 4 tables. Customer table hiding behind the product table. And we can see that diagram. So if we click here and ask for database, oops, no, sorry, relationships. We open this window and we'll see, oops, let's close down these tables. Here we go, it's back again. Here's our relationships. The relationships between our 4 tables: customer, product, sales order, and sales order product. So they're the 4 tables in the KWare database. And this is the JET version of the KWare database. So we're using Microsoft Access here, the application Microsoft Access, to open the file that you downloaded from the week 1 page. The file that you opened is a file that's used with a database engine called the JET engine. We'll talk more about that later. So there is the KWare database available to you through Microsoft Access. Now the full sample data for the KWare database is shown on this page here in the study guide. So that's a fairly useful page. You might want to print a copy of that out and pin that on your wall, because when you're formulating queries, even the queries for the first assignment, these are the 4 tables that you'll be using. These are the 4 tables that you'll be extracting data from. So having easy access to and making it easy for you to check what data is in those tables could be convenient. So a little bit of database jargon. Notice that in the Microsoft Access diagram for the KWare database, notice this little key symbol next to CID here. Again, next to SOID here, PID up here. What do these key symbols represent? Well, what they're doing is they're flagging the fact that CID values are important. Well, obviously we saw that CID values also appear in the sales order table. And yes, they are important, because the CID value in a row in the sales order table identifies the customer who placed that order. So these CID values, values that can uniquely identify a customer, are important. So what this key symbol here represents is the fact that the CID column in the customer table is a key column. It's the primary key column. It's the column that holds values that are used to uniquely identify a row in that table, or can be used to reference or point to a row in that table. So primary keys, an important part of relational databases. And when we see CID values in the sales order table, we say that the CID column in the sales order table is a foreign key. A foreign key meaning that there are values in here that refer to rows in another table, a related table, the customer table. So primary keys and foreign keys are a really important part of relational databases, and we'll hear lots more about them later on. Now the SQL language has statements within it that can be used to both create relational databases and do other things with relational databases, including querying relational databases, that is describing data that we want to retrieve from or extract from a relational database. So statements to create tables, statements to select data from tables. So here is an example SQL create table statement, creating the customer table. And here the statement to create the sales order table. And notice that as the part of the create table statement for the customer table, we include here a clause that says the primary key for this table is the CID column. Notice also that in the create table statement for the sales order table, we specify here the name of the primary key of that table, which is the SOID column, and we also identify a foreign key. So we say CID is a foreign key. It holds values that reference CID values in the customer table. Primary keys and foreign keys, very important, and we can create tables with primary keys and foreign keys using the SQL language. Study Guide makes a couple of other points about foreign keys. Notice that in creating the customer table, we define the columns that we are creating in that table. We're also defining a data type for each of those columns. So here we're saying that values that go into the CID column must be integer values. Now, not surprisingly, when we define the CID column in the sales order table, we also define that column as integer. That makes sense because obviously values in this column need to match values in the CID column in the customer table. So data in a database is a very important resource, and we'll be talking a fair bit about mechanisms that we can use to protect the stored data to make sure that it's correct. Defining data types for our columns is an example of one mechanism that we can use to protect the correctness of the stored data. But defining CID columns as int, that means that we can't have any textual characters or alphabetic characters appearing in those columns. It can only be numeric values. Now, notice that in the definition of the CID column for table sales order, we also declare that column as not null. What does that mean? Well, what it means is that you must enter a value into that column. That column cannot be empty. In SQL, in relational database, we talk about nulls. So a null is what you have if you don't have a value for a column. So by declaring the CID column as not null, it means that when a row is inserted into the table, a CID value must be provided for that column. And it means that if an update is performed against that table, a CID value cannot be set to null. It must always hold a value in that column. What's the significance of that? Well, the significance is that what we're saying here is that every sales order must be related to a customer. We cannot tolerate having rows recorded in the sales order table unless we know who the customer was who placed that order. We must hold a CID value in each sales order row. So primary keys, foreign keys, very important. Data types are important for protecting the correctness of stored data, and nulls, which are an important and interesting part of SQL language and relational databases. Next up, SQL.